Good morning. Welcome to the 2025 International Congress of Basic Science Award announcements. I'm Bong Lian, Secretary General of the ICBS. It is my great honor to be your MC this morning. Thank you all for joining us as we celebrate and honor the outstanding achievements of some of our fellow scientists. We're thrilled to have a distinguished audience with us this morning, both online and in this room. First, let me introduce our distinguished guests. They are Professor Xingtong Yao, President of the ICBS, Fields Medalist, the Dean of Children's College. Professor Andrew Chi Yao, 2024 Basic Science Lifetime Award Laureate, Turing Award Laureate, and academician of the Chinese Academy of Sciences. Professor Kocher Birka, Fields Medalist, and the Professor of Tsinghua University. Professor Yifang Wang, academician of the Chinese Academy of Sciences, recipient of the Future Science Prize in Physical Sciences. To preside over the award announcement this morning is the President of the International Congress of Basic Science. Please welcome Professor Xingtong Yao.
Good morning, good afternoon, and good evening to all our esteemed guests, colleagues, and friends joining us from around the world for the 2025 International Congress of Basic Science press conference. It's my great honor and privilege to be with you today at this distinguished gathering to announce the winners of the 2025 ICBS Basic Science Lifetime Award. The award represents our highest recognition of scientific excellence, celebrating those who have dedicated their lives to pioneering discoveries that have reshaped the very foundations of their disciplines. Established in 2023, the ICBS Basic Science Lifetime Award honors extraordinary scientists who are both outstanding and innovative in three basic science disciplines, namely mathematics, physics, information science, and engineering. Over the course of 30 years or more, these individuals have not only advanced human knowledge that have also fundamentally transformed the landscape of scientific inquiry. Their relentless pursuit of discovery has set new standards, inspired generations, and paved the way for groundbreaking applications that impact our world in a profound way. The ICBS Organization Committee has worked diligently to ensure the integrity and prestige of these awards. Leading scholars from around the world, recognized for their own contribution to the advancement of science, were invited to nominate candidates who exemplify the highest standards of excellency. Sitting in this year's committee are members of national academies from China, the United States, the United Kingdom, France, Germany, Norway, Japan, and other countries. The scientific committee also includes laureates of some of the most prestigious international honorees, such as the Nobel Prize, the Fields Medals, the Turing Award, the World Prize, and the Saul Prize. Their collective expertise ensured that only the most deserving candidates were chosen for the award. Following an extensive and rigorous evaluation process, the 2025 Basic Science Lifetime Award has been conferred upon the six distinguished scientists. Each of these laureates has made significant long-lasting contribution to their respective fields, leaving an indelible mark on the scientific community. Now I'm delighted to introduce our first announcer, who will present the first category of our distinguished awardees. So ICBS Science Lifetime Award in Mathematics, please join me in welcoming Professor Coach Berker.
Good morning to everyone. It's with great honor that we recognize Shigafumi Mori, a towering figure in mathematics whose groundbreaking contributions to algebraic geometry have reshaped the discipline and inspired generations of mathematicians. Born on February 23, 1951 in Nagoya, Japan, Mori's journey from a curious student to one of the most influential mathematicians of our time is a story of brilliance, perseverance, and transformative innovation. Renowned for his fundamental work in the birational classification of three-dimensional algebraic varieties, Mori's pioneering research has had a profound impact on the field, earning him the prestigious Fields Medal in 1990. Mori completed his PhD in 1978 at Kyoto University under the guidance of Masayoshi Nagata, with a thesis titled The Endomorphism Rings of Some Abelian Varieties. Early in his career, he held visiting positions at several leading institutions, including Harvard University, the Institute for Advanced Study, Columbia University, and the University of Utah. In 1990, he became a professor at Kyoto University, where he has continued to influence the field through his research and mentorship. Mori's most celebrated achievement is his contribution to the extension of the classical theory of minimal models originally developed for algebraic surfaces to dimension 3. This work, known as the minimal model program, allows for the classification of three-dimensional algebraic varieties by introducing controlled singularities. His innovative approach has opened new avenues for research in higher dimensional algebraic geometry, and the minimal model program remains an active and vital area of study. In addition to his mathematical contributions, Mori has played a significant role in the global mathematical community. He was elected president of the International Mathematical Union, becoming the first leader of the organization from Asia. His leadership has helped to promote international collaboration and advance the field of mathematics worldwide. Mori's accolades extend beyond the Fields Medal. In 2021, he was awarded the Order of Culture, one of Japan's highest honors, in recognition of his exceptional contributions to mathematics and culture. Through his groundbreaking research, leadership, and dedication to advancing mathematical knowledge, Shigefumi Mori has solidified his legacy as one of the most influential mathematicians of the modern era. As a professor at Kyoto University, Mori has been a dedicated mentor, nurturing the next generation of mathematicians and ensuring that his legacy will endure. His unwavering commitment to excellence, innovation, and collaboration exemplifies the very best of the mathematical spirit. Today, we celebrate Shigefumi Mori, a visionary mathematician, a transformative leader, and an inspiration to us all. His work has not only advanced the frontiers of knowledge, but also strengthened the bonds that unite the global mathematical community. It's with immense pride that we present the 2025 Basic Science Lifetime Award to Shigefumi Mori, a true luminary of our field. And for the second winner, it's with great honor that we celebrate George Lustig, a mathematician whose profound and far-reaching contributions have transformed the landscape of representation theory, algebraic geometry, and related fields. Born on May 20, 1946 in Timisoara, Romania, Lustig's journey from a young student to one of the most influential mathematicians of our time is a testament to his extraordinary intellect, creativity, and dedication to the pursuit of knowledge. Lustig's academic journey began at the University of Bucharest, where he earned his undergraduate degree in 1968. He then moved to the United States to pursue his PhD at Princeton University under the guidance of Michael Atiyah and William Browder, completing his thesis on Novikov's higher signature in 1971. This early work showcased his exceptional talent and set the stage for a career marked by groundbreaking discoveries and deep insights. Lustig's most celebrated contribution lie in the field of representation theory, particularly in the study of algebraic groups, Hicke algebras, and quantum groups. His pioneering work on the Deligne-Lustig theory in the 1970s, developed in collaboration with Pierre Deligne, revolutionized the understanding of representations of finite groups of Lie type. This theory provided a powerful framework for constructing and analyzing representations with profound implications for number theory, algebraic geometry, and combinatorics. In 1990, Lustig introduced the concept of canonical basis for quantum groups, a groundbreaking development that connected representation theory to other areas of mathematics and physics. His work on canonical bases, along with his development of the Kazhdan-Lustig polynomials, the Lustig-Vaughan polynomials, and the Lustig conjecture on characters of irreducible representations of algebraic groups, has had a lasting impact on the field. These contributions not only advanced the theoretical foundations of representation theory, but also opened new avenues for research in geometric representation theory, mathematical physics, and beyond. Lustig's influence extends beyond his research. As the Abdul Noor Professor of Mathematics at MIT, he has mentored many students and collaborators, inspiring them to explore the frontiers of mathematics. His lectures and writings are renowned for their clarity and depth, making complex ideas accessible to a wide audience. Throughout his career, Lustig has been recognized with numerous prestigious awards, including the Cole Prize in Algebra, the Brouwer Medal, the Leroy Steele Prize for Lifetime Achievement, the Shaw Prize in Mathematics, and the Wolf Prize. He is a member of the National Academy of Sciences, the American Academy of Arts and Sciences, and the Royal Society, among other distinguished institutions. These accolades reflect not only his intellectual brilliance, but also his profound impact on the mathematical community. George Lustig's work has redefined the boundaries of mathematics, bridging diverse fields and inspiring generations of mathematicians. His legacy is one of innovation, rigor, and a relentless pursuit of understanding. It's with deep admiration and gratitude that we present the 2025 Basic Science Lifetime Award to George Lustig, a true mathematical pioneer whose transformative contributions will continue to shape the future of mathematics for years to come.
Now let us welcome Professor Yifan Wang, who will present the ICBS Basic Science Lifetime Award in Physics.
It is with great immense pride and admiration that we honor David Jonathan Gross, a preeminent figure in theoretical physics, whose groundbreaking contributions has profoundly shaped our understanding of the fundamental forces of nature. Born on February 19, 1941, in Washington, D.C., Gross had dedicated his life to unveiling the deepest mysteries of the universe, earning him a place among the most influential physicists in the modern era. Gross' academic journey began at the Hebrew University in Jerusalem. where he earned his bachelor's degree in 1962. He then pursued his PhD at the University of California, Berkeley, under the guidance of Jeffrey Cho, completing his thesis on the high-energy behavior of strong interactions in 1966. His early work foreshadowed his lifelong fascination with the fundamental forces and the particles that govern the cosmos. After completing his doctorate, Gross held a junior fellowship at Harvard, where he began to establish himself as a rising star in theoretical physics. Gross' most celebrated achievement came in 1973, where he and his student Frank Wilczek, in parallel with David Politzer, discovered the property of asymptotic freedom in quantum chronodynamics. This groundbreaking discovery revealed that the strong nuclear force, where binds quarks together to form protons and neutrons, becomes weaker at shorter distances. This insight made possible a theoretical understanding of the strong force, making it possible to complete the standard model of particle physics. It also revolutionized the general understanding of quantum field theory. From this monumental contribution, Gross, Wilczek, and Politzer were awarded Gross, Wilczek, and Politzer were awarded the Nobel Prize in Physics in 2004. Their work remains a cornerstone of modern physics, influencing countless experiments and theoretical developments. Beyond his work on asymptotic freedom, Gross has made significant contributions to string theory, quantum field theory, and the unification of fundamental forces. His discovery of heterotic string theory with Jeff Harvey, Emil Martinek, and Ryan Rohm helped establish string theory as the leading framework for understanding quantum gravity and the potential unification of all fundamental forces. Gross' ability to bridge deep theoretical insights with experimental implications has made him a central figure in the quest for a unified theory of physics. Throughout his career, Gross has held distinguished positions at Princeton University, where he served as the Thomas Jones Professor of Mathematical Physics, and at the Kavli Institute for Theoretical Physics at the University of California, Santa Barbara, where he served as the director from 1997 to 2012. Under his leadership, KITP became a global hub for collaborative research, fostering groundbreaking discoveries and nurturing the next generation of physicists. Gross' contributions have been recognized with numerous accolades, including the Dirac Medal, the Harvey Prize, and the MacArthur Fellowship. He is a member of the National Academy of Sciences, the American Academy of Arts and Sciences, and numerous other prestigious institutions. His influence extends beyond his research, as he has been a passionate advocate for science education, international collaboration, and the role of science in addressing global challenges. David Gross' legacy is one of the intellectual brilliance, visionary leadership, and unwavering dedication to the pursuit of knowledge. His work has not only advanced the frontiers of physics, but also inspired countless scientists to explore the deepest questions of the universe. It is with profound respect and gratitude that we present the 2025 Basic Science Lifetime Award to David Gross, a true giant in theoretical physics, whose contributions will continue to illuminate the path of scientific discovery for generations to come. The second one goes to Professor Samuel Zhao Zhongding. It is with profound respect and admiration that we honor Samuel Zhao Zhongding, a pioneering physicist whose groundbreaking discoveries have profoundly advanced our understanding of the fundamental building blocks of the universe. Born on January 27, 1936, in Ann Arbor, Michigan, and raised in China, Ting's journey from a determined student to one of the most influential physicists of the modern era is a story of perseverance, intellectual brilliance, and transformative contributions to science. Ting's academic journey began at the University of Michigan, where he earned his bachelor's degree in physics and mathematics in 1959, followed by a PhD in physics in 1962. His early work in particle physics demonstrated his exceptional talent and set the stage for a career marked by groundbreaking discoveries. After completing his doctorate, Ting held research positions at the European Organization for Nuclear Research and Columbia University, where he began to establish himself as a rising star in the field. Ting's most celebrated achievements came in 1974, where he had a team of researchers at the Brookhaven National Laboratory in the discovery of the GFPSI particle. This groundbreaking discovery, made independently by Ting's team and a group led by Burton Richter at the Stanford Linear Accelerator Center, provided the first experimental evidence for the existence of the charm quark, a fundamental particle predicted by the quark model. The discovery of the GFPSI particle confirmed the existence of the fourth quark and played a pivotal role in the development of the standard model of the particle physics, which described the fundamental particles and the forces of nature. For his monumental contribution, Ting and Richter were jointly awarded the Nobel Prize in Physics in 1976. Beyond his work on the GFPSI particle, Ting has made significant contributions to high-energy physics through his leadership of major international experiments. In 1995, he initiated the Alpha Magnetic Spectrometer project, a state-of-the-art particle physics detector designed to study cosmic rays and search for evidence of dark matter and antimatter in space. The AMS installed on the International Space Station in 2011 represents one of the most ambitious and sophisticated experiments in the history of physics. Ting's vision and demonstration have made the AMS a cornerstone of modern astrophysics and cosmology, with the potential to revolutionize our understanding of the universe. Throughout his career, Ting has held distinguished positions at the Massachusetts Institute of Technology, where he is the Thomas Dudley Cabot Professor of Physics. His leadership and mentorship has inspired countless students and collaborators, fostering a legacy of excellence and innovation in the field of particle physics. Ting's contributions have been recognized with numerous accolades, including the Ernest Orlando Lawrence Wood Award, the De Gasperi Award, and the Golden Plate Award. He is a member of numerous international science academies, including the U.S. National Academy of Sciences, the Soviet Academy of Sciences, the American Academy of Arts and Sciences, and the Chinese Academy of Sciences, reflecting his profound impact on the global scientific community. Sam Ting's legacy is one of intellectual curiosity, relentless determination, and transformative discoveries. His work has not only advanced the frontiers of physics, but also inspired generations of scientists to explore the deepest mysteries of the universe. It is with deep gratitude and admiration that we present the 2025 Basic Science Lifetime Award to Sam Ting, a true giant of experimental physics whose contributions will continue to illuminate the path of scientific discovery for years to come.
Let's now welcome Professor Andrew Qizhi Yao, who will present the ICBS Basic Science Lifetime Award in Information Science and Engineering.
Good morning. We have two winners in this category. For the first one, let me introduce Professor Stephen Chu. It is a great honor that we celebrate Stephen Chu, a renowned scientist and engineer whose marvelous contributions have transformed our understanding of energy, climate, and technology. Chu's academic journey began at the University of Rochester, where he earned a bachelor's degree in mathematics and physics in 1970. He then studied and received his PhD in atomic physics in 1976 from UC Berkeley. One of his most celebrated scientific achievements came in the 1980s when Chu developed laser cooling and trapping techniques for atoms. This groundbreaking work, conducted with his colleagues at Bell Laboratories, allowed scientists to slow down and manipulate atoms using laser light, effectively cooling them to temperatures near absolute zero. This breakthrough enabled the study of atomic behavior with unprecedented precision and laid the foundation for advancement in quantum physics, atomic clocks, and the development of both Einstein condensates. For this transformative contribution, Chu was awarded the Nobel Prize in Physics in 1997, alongside Claude Cohen-Tannoudji and William Phillips. Beyond his Nobel Prize-winning work, Chu has also made contributions to energy science and engineering. At Stanford University, he pioneered research in renewable energy, bioenergy, and energy efficiency, focusing on solutions to combat climate change. His interdisciplinary approach, combining physics, chemistry, and biology, has led to innovative advancements in solar energy, battery technology, and carbon capture. It is with profound admiration and gratitude that we present the 2025 Basic Science Lifetime Award to Stephen Chu, a true visionary whose contributions will continue to shape the future of engineering and the world for generations to come. Now the other winner in this category. It is with great pleasure that we would like to honor Robert Tarjan, who is an extraordinary trailblazer in computer science at Princeton University. His groundbreaking contributions to algorithms and data structures have fundamentally reshaped this field. Bob Tarjan earned his bachelor's degree in mathematics in 1969 at Caltech and a PhD in computer science at Stanford University in 1972. In the 1970s and 1980s, his innovative work on graph algorithms, particularly in developing depth-first search, strongly connected components, planarity tests, and graph decomposition, established his stature as an authoritative pioneer in this field. Bob also introduced many groundbreaking data structures, including the Fibonacci heap and the display tree. These innovations have had a profound impact on algorithm design, enabling faster and more efficient solutions to a wide range of computational problems. Throughout his career, Tarjan has been recognized with numerous prestigious awards, including the Turing Award in 1986, which he shared with John Hopcroft for their fundamental contributions to the design and analysis of algorithms and data structures. Bob is also a recipient of the Nevelina Prize in Information Science, the Paris Canalakis Theory and Practice Award, and the Blaise Pascal Medal, among others. Robert Tarjan's legacy is one of innovation, rigor, and relentless pursuit of excellence. His work has not only advanced the frontiers of computer science, but is also widely used in applications ranging from network analysis to compiler design. It is with deep admiration that we present the 2025 Basic Science Lifetime Award to Robert Tarjan, whose contributions have had a profound and lasting impact on information science and engineering.
Well, congratulations to the winners of this year's ICBS Basic Science Laureate. You are really role models for the scientific society around the world. Congratulations.
Thank you, professors. And once again, congratulations to the new Basic Science Lifetime Award laureates. This concludes the Lifetime Award announcement. Thank you. The post-announcement press conference shall start momentarily. I would like to invite some of our distinguished colleagues to join us for the Q&A session. Let us welcome Professor Qingshan Jia from the Department of Automation at Tsinghua University, Professor Peng Shan from the Yao Mathematical Science Center at Tsinghua University, and Professor Qi Yan from the Institute of High Energy Physics at the Chinese Academy of Sciences. Welcome. The media is welcome to raise your hand and ask questions. Correspondence from People's Daily.
Yes. 我可以用中文提问吗？好的，好的。很高兴来到今天的这个发布会。然后让我想起了去年和前年的这个 ICBS 上都有非常的美好的回忆，听到了很多很有趣的一些讲座。然后我的问题想问邱先生，能否透露一下今年的 ICBS 会有什么新的亮点和看点？然后我们今天发布了我们这些获奖者，我们有没有幸在几个月后的这个时候能够一睹他们的风采，跟他们做交流？谢谢。
谢谢。这个我们一年比一年好。今年我们看到6个得奖者，其中有3个是诺贝尔得奖，一个图灵奖，一个 Fields-Medal 得奖。每一个都是当今最伟大的科学家。我希望我们的学者们能够跟他们有深入的交流，让我们的同学们也能够跟随他们的脚步，向这个伟大的科学事业前进。他们7月中会到这个中国来，拿那个参加我们的仪式跟拿奖，也会跟我们的同学们、跟我们的这个老师们交流。我想这是一个盛会。我们除了这6个终身成就奖以外，我们还有一个科学前沿奖，那个是有140多个学者会到我们这边来，这些都是世界上最有活跃、最有能力的学者，他们代表这几年来在数学、物理跟工程上面最前沿的这个活动的学者，他们的到来会对我们这个 中国的学者会有很大的鼓励，也期望我们的同学能够听他们的讲课也期望这个我们的从海外来的伟大的学者们能够了解一下中国的情况，晓得中国的情况并不是外边媒体的宣传这样子，实在是一个有能力同时为和平为这个科学来贡献的一群重要的学者们希望全世界的学者能够互相帮忙，互相了解这个科学的最前沿。我想我们一年比一年好，是因为大家都看到我们这个开这个会是真正为学问为人类的前途来创造的一个大会。
Correspondence from CCTV.
感谢提问机会，我想问一个问题给姚先生。就从 OpenAI 到 DeepSeek， 我们看到一个有趣的现象是，生成式人工智能它的技术的主力军似乎大多数是90后、95后甚至00后。那为什么会有这样的一个现象？这种现象背后的一个技术代际跃迁的逻辑是什么？谢谢。
我想这是一个非常好的问题，就是为什么我们现在在人工智能这个领域特别有这么多年轻的学者，他在里面做出一些非常伟大的贡献。我想这个一个其实最主要的原因就是，虽然人工智能它这门科学已经存在了很多年，它和计算机科学差不多一样的时代，都是已经有了70-80年的历史但是最近的这个大模型的一个出现，它改变了人工智能它这个学科的整个形式。就是大模型的出现，它是说我们发现了在以前试过的很多条路线里面，有一条它给了我们一个非常想不到的惊人的一个能力，它甚至解决了图灵测试这一个原始的一个最重要的问题那么这条路线它从技术上来讲，它没有那么像数学物理里面它所需要那么多复杂的一个数学跟物理的技术，所以这使得在人工智能里面做研究，在前沿研究里面的门槛，在知识的一个层面比较容易着手，容易接近。所以很多的年轻人他在学了大学的本科的课以后，他就已经看到人工智能的前沿。那么所以这个就是为什么我们看到 DeepSeek 它这100多个也了不起的年轻人，他们能够做出这些工作的结果。我觉得这件事情它是非常 exciting， 它使得我们人工智能这个学科它发展的前景，尤其是在中国，我觉得有了一个非常有利的地位。
Correspondence from CGTN.
Thank you. We have learned that China is actively bidding for the ICM 2030, which is the International Congress of Mathematicians. Why is the bid being made at this particular time? And what are Beijing's unique advantages in the field of mathematical research? Thank you.
Well, I guess I will answer this question. Well, actually, it starts about 2 or 3 years ago when we have this conference, ICBS, being held in Beijing City. Our friend, Professor Nakajima, who is the president of IMU, International Math Union, came. He came in 2023 and 2024. And during the meeting in July in 2023, he expressed very interesting comment to me and to some of our friends. He said it was very impressive that we in China was able to run a very major conference like ICBS in a matter of half a year preparation. You remember in 2023, only beginning in January of 2023, the COVID is considered to be over. And only starting then, we were able to charge forward to start the conference in July. So only half-year preparation. He said we did a great work. That's what he said. He said, on the other hand, you talk about 4 years in general for the International Congress to be held. It takes 4 years to prepare. So he thinks it's a great thing that we can do it. And he said the same thing again next year in 2024. He came again. So he invited us to apply to bid for the 2030 Congress in Beijing. Well, at the time, we were only there's no other country bidding for it. But time has evolved. Now there are 2 other countries that are bidding for it. So now we are getting more competitive era that we need to prepare a good and rich scientific atmosphere for the Congress to recognize us and for IMU to recognize us. But we are very confident about it because now we have a large group of distinguished mathematicians all over the country. I would say more than 80% of the most prominent mathematicians of China are joining effort to make this bid for the ICM. And it will be discussed this year for sightseeing, and then next year they will make the final decision. And we have the cooperation with Korea and also with the Beijing City to look into the detailed support. And I think the government is supporting us strongly, and the government has strong interest to see this coming to China. The reason is that the Chinese mathematics are taking a very, very important turn in the last few years. Many of our most distinguished mathematicians all over the world are coming back to China after they have studied in America, in Europe, in many different places, and they feel very comfortable to be back to China. And at the same time, in the last few years, we are training our own students. I would say that our students in both high school and undergraduate college students are as good as any in the whole world now. Some of them are even better than most of the talents in the world. And this is time for us to encourage our students to charge on. Although it may be a little bit tough to get the Fields Medal, the highest honor, but we are looking forward to see some of the young mathematicians will be awarded. But at least we hope to see that many of our young students and young faculties will be invited to give talks in the Congress. And we are looking forward to it. It's not just an honor, but I think it's a great encouragement for our young students to show their strength for this Congress, just like the Olympics, which has encouraged many, many important young students and young athletes to be strong in China. And so I expect in 5 years' time, which means 2030, this will create a turning point for the Chinese mathematics development. and will mean by the year 2030, Chinese mathematics community will become one of the major leaders in the world in mathematics science. And I'm very confident that will happen. And this Congress would be a starting point for our development. And I believe IMU would appreciate that a ICM could mean a big deal for a country. And I think our young mathematicians and young faculty and young students would be very much encouraged if we have the way to show our strength. Thank you.
In the interest of time, I think we will take just one more question. China News Agency.
Thank you so much for the interview chances, and it's really nice to hear the distinguished panelists to give us so much inspirations on science. And my question is for Professor Andrew Yao concerning AI development. So this year, Chinese artificial intelligence development seems to have reached a small climax with technologies like DeepSeek and humanoid robots entering the lives and the perspectives of normal people. And amid this AI boom, what are the crucial reflections we should consider, and what areas still need improvement and development, such as AI hallucinations and ethics? And what role does international collaboration play in driving global AI development? And what role does governments, businesses, and scientists each play in this progress? Thank you.
Well, there's a lot of questions, so I'm just going to answer some of them. Regarding what are the main difficulties and what are the opportunities for future AI, I'll just mention two. The first one is that we still need a lot of theory, a theoretical understanding of AI, so that we can control them better, and also we can design better AI algorithms. And the basic point is that right now, AI in the frontier almost runs like an experimental science, so that we have a lot of success, a lot of data, but we don't really understand why. So I think for the next breakthrough, in order to go forward, we have to have a fundamental understanding. And the second thing that for the future that we need to pay attention to is the AI safety question. And I think the phenomena that you mentioned, such as hallucination, I think these sort of things pose hazard for using AI for the critical applications, because in the critical missions, you really cannot afford any mistake. And so to understand the reason for this insecurity is very important. And so the study of AI safety, in my opinion, actually has another important reason, namely that a lot of people think that there's a conflict between development of AI and AI safety. And so people think that we have to make a choice or we have to make a balance. But actually, if you think about it, these two things eventually will be the same thing. If you can design the safest AI techniques, then you are going to have the market in a tremendous advantage. People will buy it. And so the study of safety, therefore, is really critical for the future, both because of the malicious abuse question and because of the commercial success question, and also particularly, this is an important point for the for the announcement, the press announcement today, namely that it actually is scientifically very, very, very important. We really have to understand the safety question, and in order to do that, it's equivalent to understand AI in a fundamental way, just like the achievements of the winners of the Basic Science Lifetime Awards. I think we need tremendous, so that's a tremendous challenge and a tremendous opportunity lying there.
Thank you so much.
Thank you. Thank you, ladies and gentlemen. Thank you, professors. This concludes our Q&A session this morning. We shall take a short break, and after the break, we shall proceed to announce the 2025 Frontiers of Science Award. Thank you. Welcome back. Before we announce the next award, I would like to introduce our distinguished guests on stage. Once again, Professor Xingtong Yao, President of ICBS. Professor Nikolai Reshetkin from the Yao Mathematical Science Center at Tsinghua University. Professor Song Wei from Yao Mathematical Science Center at Tsinghua University. Professor Qingsan Jia from the Department of Automation at Tsinghua University. Professor Babak Hakikat, also from the Yao Mathematical Science Center at Tsinghua University. Dr. Wenhao Ao from the Academy of Mathematics and System Science at the Chinese Academy of Sciences. To preside over the 2025 Frontiers of Science Award announcement, may I present to you again Professor Xingtong Yao.
Ladies and gentlemen, esteemed colleagues, and distinguished guests, it's with great honor and enthusiasm that we announce the recipients of the 2025 Frontier of Science Award, a prestige recognition presented by the International Congress of Basic Science. Today, we celebrate the achievements of the brilliant minds in mathematics, theoretical physics, and theoretical computer and information science, fields that drive the advancement of human knowledge and shape the future of scientific discovery. In an era of rapid technological progress, closer collaboration among mathematicians, computer scientists, and physicists is more essential than ever. By fostering interdisciplinary exchanges, we can better understand the later developments, breakthroughs, and push the boundary of what is possible. Established in 2023, the Frontier of the Science Award honors research of outstanding scholars, significance, which with a particular emphasis on influential contributions from the past 5 years, while also recognize exceptional works from the past decade. This award celebrates groundbreaking scientific advancement from across the globe, bringing together brilliant minds from different countries and offering us a unique opportunity to gain insight into their extraordinary work. The primary goal of this award is to highlight the frontiers of fundamental science, inspiring young researchers to set ambitious goals, achieve groundbreaking results early in their careers, and contribute their intellectual and energy to unraveling the mysteries of the natural world. Additionally, the award fosters collaboration between China and the international scientific community, while showcasing China's progress in research and innovation. This year's recipients include distinguished figures such as Fields Medalist, Kochi Berger, Machine Conservation, and Vygotsky, as well as Breakthrough Prize in Fundamental Physics, Roland and Tom Sinus, and Ho Chin Wen Longley. The award also highlights emerging young scientists and pioneering female researchers, reinforcing our commitment to diversity and inclusivity in the scientific community. Now it's my great honor to invite Bong Liang to the stage, who is here. Having led a team of hundreds of experts, he has devoted immense time and effort for this rigorous and meticulous selection process. So please join me in welcoming him.
Thank you, Professor Yao. As the ICBS Secretary General, I'm very honored to be charged with overseeing the nominations and the selections of candidates for this year's Frontiers of Science Award. First, allow me to tell you more about the award. The award is divided into 40 sections, 24 in mathematics, 5 in physics, 11 in theoretical computer and information sciences. Peer-reviewed papers in each of these 40 research areas published within the last 10 years are eligible. Our main criteria of nomination and selection is that a winning paper should represent a major breakthrough in one area. In addition, the winning paper has been vetted and voted for by 3 separate panels of international experts. This year, we are very fortunate to have received some 4,000 nominations. Typically, 2 to 4 awards go to the best papers in each of the 40 sections selected by the judges. I'm happy to announce that we have a total of 148 excellent papers winning the award this year, with 86 in mathematics, 26 in physics, and 36 in theoretical computer science and information science. And now, it is my pleasure and honor to present the 2025 Frontiers of Science Award winners. Three awards go to algebraic and geometric topology. Awards go to commutative algebra and algebraic geometry. Four awards go to discrete geometry and graph theory. Four awards go to differential geometry. Go to symplectic and differential topology. awards go to calculus of variations and discrete optimization. Four awards go to combinatorics. Two awards go to numerical analysis. Four awards go to scientific computing. Four awards go to probability theory and stochastic analysis. Two awards go to statistics. Four awards go to dynamical systems and ergodic theory. Three awards go to mathematical analysis. Two awards go to functional analysis and operator theory. Four awards go to geometric analysis. Four awards go to one and several complex variables. Two awards go to partial differential equations. Two awards go to general relativity. Four awards go to mathematics of string theory and condensed matter. 3 awards go to lead theory and representation theory. Four awards go to algebraic number theory and arithmetic geometry. Four awards go to analytic number theory. Three awards go to ordinary differential equations, special functions, and D modules. Four awards go to category, logic, and homological algebra. Our next presentation is for Frontiers of Science Award in Physics. 3 awards go to astrophysics and cosmology theory. Three awards go to condensed matter physics. Four awards go to formal quantum field theory. Four awards go to particle physics phenomenology. Four awards go to string theory and quantum gravity. Our next presentation is for theoretical computer and information science. Four awards go to AI for physical sciences. 1 award goes to AI science and machine learning. 3 awards go to mathematical modeling and simulations. 4 awards go to big data technology. 2 awards go to bioinformatics and AI for life sciences. 3 awards go to cryptography and information security. 4 awards go to graphics and geometric computing. 4 awards go to robotic science and systems. 4 awards go to image and signal processing. 4 awards go to theoretical computer science. 3 awards go to biophotonics and computational optics. 'That concludes our presentation. Let's congratulate our Frontiers of Science award winners. Before we adjourn, we're happy to open the floor and take a few questions from the audience. I presume there are members of the press and students and postdocs among our audience. Yes.
Hi, I'd like to ask a question to Rashidi Professor. How do you view the effect efforts of probability in rigorously analyzing the statistical physics models, particularly when they prove some results that physicists consider established through no rigorous method. What insight can their work offer to mathematical physics? Additionally, when probabilists disprove some fact or conjecture widely accepted in a field, how does this impact the way physicists refine or maybe reinterpret such models?
Thank you. This is a very important question. And unfortunately, the true answer would be quite long. So I'll be happy to explain it to you after this. But I just want to say that the awards that were given now, basically, they answer your question. It's a fantastic collection of new results, and many of the results, especially in mathematical physics, they exactly address your question. So it's a very interesting interface between physics and mathematics that's important to both, to mathematics as the source of inspiration and new ideas, to physics as the source of new tools. So that's probably what I want to say.
Thank you. There's a correspondence from China Youth Daily.
我是新华社的记者，我问一下那个邱老师，就是今年的这个基础科学大会大概是什么时候举行？然后在内容安排上，有哪些亮点哈？有什么值得期待的？就是请您把这个今年的大会的一些新的情况给我们介绍一下。然后另外一个问题想提给尼古拉先生啊，尼古拉老师，我想问您一下，就是您怎么看待就是中国来举办这个我们清华举办这个国际基础科学大会，包括今天颁发这么多奖项这件事情哈，然后觉得这些事情会对我们基础科学的这个发展进步，包括国际交流合作有些什么样的意义？这两个问题。
我们这个国际基础科学大会，每一年都预备在7月的后2个礼拜，所以是7月13号，我们这个大会的这个开幕典礼开始，然后7月14号跟住2个礼拜，我们在法有我们的念西湖应用数学研究院里边开这个大会。这个基础科学的最有趣的事情是往往有大突破，你可能不晓得，这个突然间会看到，不是这种5年计划或者10年计划能够做出来的事情。我们看到有些出名的这个大突破，好像我们这个今年我们看到王红这个女士的突破在美国，当时我们大家都不晓得她会做出这么重要的问题，突然间我们看到了，也听到了，也很高兴。所以我们因为这个大会会带来我们很多惊喜，我们也邀请了这些所有在国外跟国内重要的学者的研究，在这个大会里边会给我们讲，我们因为这次有很多重要的这个演讲，会带给我们很丰富的这个内容，让我们的学习从这个 这个终身成就奖，这都是一大事以外，我们看到年轻的学者他们做出的成就也让我们很佩服，很这个崇拜的。所以我们会看到一方面看到我们既仅完成的伟大的学问的基础，也会看到一些惊奇，就是突然间有新的想法、新的方法来解决重要的问题，我想是毫无疑问的。She is asking you.
Yes. So for the first question, there were several questions, so I'll try to answer all of them. I think this forum is very important internationally because, I think during the second time, there was some skepticism that where you will get so many frontier awards, I mean, as scientific contributions. And I don't hear these questions anymore. It shows that research worldwide is actually at a very high level, and every year something fantastic is happening. So that's one of the effects of this forum internationally. It's also very important, I think, for China, because many international scholars come and they see New China and they see the level of students, of young researchers, and that's very important. For Tsinghua, so it's important that it's on the spot internationally, and also, most importantly, students and young researchers can participate in this forum, and they see the leading scholars in the world. They don't have to go anywhere; they come here. So I think I answered some of the questions, hopefully all of them.
Thank you. In the interest of time, we'll take just one more question. Yes.
这个工具在理解量子引力理论中扮演的角色。您认为这个数学与物理的跨学科合作在推动这一领域发展中起到了什么样的作用？
我想刚才好像也有问题，问到了这个，然后尼克莱老师也做了很好的回答。其实，在我们的这个前沿科学奖的这个得奖名单上，我们看到很多研究其实都是在数学和物理的这个交叉学科。然后数学其实它有很多就是非常先进的工具，能帮助物理学家来解决问题。但同时呢，就是在物理学中，有的时候大家比较大胆，就是说有一个想法，然后我先不管它这个数学上对不对，我先试一试能不能得出有趣的结论。反而这样的话，其实能够给出一些这个非常有趣的结果，然后让数学家来启发数学家去看这个东西在数学有什么更深的影响，有没有想办法去严格的证明它。所以从历史上，其实数学和物理就一直是像双胞胎一样在这个发展起来的。就像牛顿建立发现万有引力，其实同时他也同步的发明了微积分，所以他们就是一起生长，然后现在也是互相促进。
Thank you for the great questions and answers. This concludes our 2025 Frontiers of Science Award announcement. Thank you all for coming, and we look forward to seeing you in the July ICBS. Thank you.